Now, it's been shown that complex movement sequences, such as long-distance running or throwing projectiles, which you can imagine were very important for early humans, were essential to the development of these so-called higher or more evolved thinking structures of the brain, the so-called neocortical structures. As I said before, the brain exists, according to some neuroscientists, not to think up wonderful poems or to appreciate the beauty in nature, but again, for one reason and one reason only, to produce adaptable and complex movements. So really underscoring here the idea that movement is critical not only to our evolution, but as we'll see in a moment, also to our survival. So if you think about the typical activities that our Paleolithic ancestors engaged in from day to day, we begin to see some correlates to contemporary activities. So if you were to take the typical hunter-gatherer, you find that a good deal of their time is spent in doing what we would call slow cardio. That is to say 5 to 10 miles of walking per day at a low intensity. It's been estimated that some hunter-gatherer species cover as much as 5 to 15 miles per day on average. Other forms of hunter-gatherer societies, so-called persistence hunters, travel even more. They go as much as 30 miles per day as they're chasing down a fast-moving animal. And it's really quite interesting when you look at the calorie expenditure that these tribes have. It's exceedingly high, and yet the amount of calories that we expend as sedentary Americans in this day and age is less than a quarter of what our bodies were designed to expend over this period of 4 million years or so. Again, looking at other types of activities of the hunter-gatherer, we see that they too engaged in their own form of resistance training. This included things like lifting, throwing, carrying objects, and these encompass functional movements such as pushing, pulling, sprinting, and jumping. Now, nowadays we call this exercise, but to our Paleolithic ancestors, this was life. This was survival. In fact, if they didn't do these movements, they would not have survived. And again, according to more recent theorists, would not have evolved. Finally, another type of activity that we would see in a typical hunter-gatherer society, again, using the hunter-gatherers as an example of how we've spent most of our time on Earth as a Paleolithic species, is we engaged in interval training. And this is brief periods of high intense activity done for short periods of time, typically no less than 30 seconds. No longer than 30 seconds. So again, the correlates here might be involved in chasing down a prey or running from a predator, and this was typical of what Paleolithic life was like. Well, another way of exploring this hypothesis that the brain was designed to move and not really to think is seen when we consider the real estate of the brain, when we consider the overall structure and organization of our brain, and we begin to think about how much of the real estate of our brain is devoted to movement. And it becomes very evident that when you look at the structure, you see that we begin with the primary motor cortex, which is the motor association that has to do with primary voluntary muscle movement. There's a good percentage of real estate here. Now, the rest of the lobes of the brain, the parietal lobe, occipital lobe, temporal lobe, and with the exception of the frontal lobe, you can see are really devoted to sensory determination and sensory experiences. So you might say that the human brain is taking in information, using this information, coordinating it in order to output some movement pattern. So we are moving in response to environmental stimuli. Okay, that's one way of looking at this organization. By contrast, you can see that the thinking part of our brain, the most highly evolved part of our brain, by contrast, is really only a small part of the overall structure and organization. When we look at it from another perspective, we see that our brain really is about sensing our environment, making movements to that environment, and changing that environment in ways that our prefrontal cortex helps us to determine. So it's an evolving theory of human evolution, and the more we look at this theory and the more we consider it, the more sense it begins to make, and you begin to think, wow, this is pretty evident. we were indeed designed to move, how is it that we tend to associate the brain with simply thinking and not much else? Well, early anatomists were aware of this in their own way when they looked at the brain, and they found that at the back of all of our brains is a structure called the cerebellum. And the cerebellum is Latin for small brain. And the reason that they called it the small brain, because they realized that it seemed to have not only an independent existence from the rest of the brain, but it also in many ways looked like a little miniature brain. And when the early anatomists began to play around and tinker with cerebellum from medieval people who had passed away, they found that the cerebellum actually had a big role in movement, in controlling movement specifically. And nowadays we realize that the cerebellum is in fact one key structure in the brain that regulates our movement. Now specifically it's involved in the organization and fine-tuning of movement as it occurs. So people with cerebellar diseases, for example, might have difficulty with walking. One example of a disease of a cerebellar disease is a tumor that's affected that area, and someone with that disease might have something called cerebellar ataxia, where they typically walk with a wide stance gait, and they have difficulty coordinating and walking. Kind of looks like the way Frankenstein might have walked, if you can imagine that. So it does have a role in regulating and coordinating movement, but we also know that this moving part of the brain, the cerebellum, has many new, or I shouldn't say new, but recently discovered connections with the thinking part of the brain. So much so that recently it's been determined that disorders of attention and concentration, disorders such as ADHD, can be treated by treating the cerebellum. Okay? But you can treat a disorder of attention by treating the part of the brain that deals with movement. And that, again, seems, when you think about this theory a little bit more, it seems to make a bit more sense. We know, for example, that you can treat Parkinson's disease, which is another manifestation of a disorder of movement, with certain types of programmed repetitive movements. We're going to be learning a little bit later about how dance therapy can affect patients with Parkinson's. What you also need to know at this point, though, is that movement and rhythm and even cadence are all aspects of movement that are regulated, or at least manipulated in some way, by the cerebellum. So the cerebellum has recently become the focus for some interventions for Parkinson's and ADHD. There's a technique that some of you may be familiar with called the Door method. Now, the Door method originates in England, and what the Door method does is it proposes to treat developmental disorders like autism, ADHD, Asperger's, some other autistic spectrum disorders, by focusing attention on movement. So somebody who's undergoing a door therapy program would, for example, learn to juggle with one hand and then eventually learn to juggle with two hands. They might also begin to learn balancing techniques by practicing on a wobble board. And again, the basic underlying idea here is that if you can train the movement part of the brain, manifested by the cerebellum, you can actually see improvements in the thinking part of the brain. So again, it's not just about focusing on what's going on in the frontal cortex when we want to think about improving the way we focus and concentrate. We also have to think about movement. Yet another final fact I wanted to leave you with about the cerebellum is that, interestingly, about 50% of the brain's neurons are actually located within the cerebellum. That's a rather surprising fact. You think about 50% of our neurons are located in this relatively small structure. Now, it's as high as 80%, depending on how you count the various subtypes of neurons, but the fact that so much real estate of our movement pathways is devoted to, is found in the cerebellum, again, gives credence to this idea that we were born to move.